Hello guys. In this video, we will be discussing about exponential equation. Now we will define our exponential equation. It is an equation in which a variable occurs in an exponent. Theorem. We have here let a be greater than 0, meaning to say it's an element of a positive number or counting numbers, and a should not be equal to 1. Then the expression a to the x equals a to the y if and only if x equals y. Now, what does it mean? It means to say that if you have a to the x equals a to the y, if they have the same base, meaning to say you can equate exponents. That's why from this equation, it will be x equals y. And this is actually vice versa. If you have x equals y, this can also be written as a to the x equals a to the y. It's because of the term if and only if. This is biconditional. Note, if a and b are any positive numbers and x and y are any real numbers, take note x and y here are our exponents. And when we say real numbers, it could be a negative number, it could be a positive number. Then we have 7 properties of the exponential equation to be followed. The first property says that if you have a to the x times a to the y, then it has a corresponding exponential expression of a to the x plus y. Which means that if you are going to multiply two exponential figures, if only they have the same sign, then all you have to do is to add exponents. How about the second property? It says here that if you have a to the x as your numerator and a to the y as your denominator, if only they have the same base, then you can just copy the base and subtract exponents. But make sure that your a here should not be equal to 0. It's because this is fraction figure, and if our denominator is 0, it will become undefined. Aside from the fact that our a here should be an element of a positive number greater than 0. Now, if we have here a to the x, the quantity of a to the x times y, this is just equal to a to the xy. This is the third property. So all you have to do is to multiply exponents. For the fourth property, you have here the quantity of AB. AB here, A and B here are actually being multiplied. Okay, A and B are separated by multiplication operation. So this is quantity of A, B raised to the power of x. So at this point, we are going to distribute x to the exponent of A and x to the exponent of B. Because this is understandable that A has an exponent of 1 and B has an exponent of 1. So this is distributive property. So this would be A to the x, B to the x. Distribute x, okay, to the exponents of A and B. How about the fifth property? This is the quantity of A over B. Raised to the power of x equals A to the x over B to the x, where B should not be equal to 0. Again, our b here should not be equal to 0 because it will make our exponential expression undefined. Aside from the fact that our base is actually focusing on counting numbers, or shall I say positive numbers greater than 0. Now at this point, we are distributing x to the exponent of a on the numerator part and exponent of b on the denominator part. The sixth property, it says that if you have a negative exponent, you can actually bring that down on the denominator part, and from the negative, it will become positive, and this is actually vice versa. If you want to let a to the x on the denominator part of this right side of the expression or equation, if you're going to bring that up, it will become a to the negative x, which is the left side of the equation. Seventh property, you have here a to the 0 equals 1. So any positive number raised to the power of 0 is equal to 1. And your a here should not be equal to 0 because there is no such thing as 0 raised to the power of 0. Aside from the fact that a here is really greater than 0, element of positive numbers. These are the properties that we are going to follow in order to solve exponential equations. And let us make use all of this and put this into reality by having the following example. So we have here three exponential equations. First, 3 equals 9 to the x. We are going to solve for x. Now, based on the first item, our left side is positive 3 and our right side is 9 to the x. Now, 3 is already in its base form, meaning to say 3 cannot be transformed into another form of exponential figure. While 9 is a perfect square, which can be written as an exponential figure 3 to the 2. Now, our main purpose is that both sides of our exponential equation must have the same base. Again, if you will try to recall our definition, it says that if you have a to the x equals a to the y, if they have the same base, then we could say that this is equal to x equals y. Meaning to say, if they have the same base, we can equate exponents. And this is what we're going to do at this point. So 3 is actually safe, so you cannot write that because you cannot transform that into another exponential figure. Well, 9 can be written as 3 raised to the power of 2. But there is still x. So what we did, we transformed 9 into an exponential figure with a base 3 and an exponent of 2, and x just copy. Now simplifying the right side, and we have to copy the left side. Now, according to this point, if you have a conflict of two exponents, then you are going to multiply exponents. This is actually 3 raised to the power of 2x. What property did we use? If you are going to recall our properties that we mentioned a while ago, it will follow the third property. According to here, if there is a conflict of exponents, then you are going to multiply. So we are actually using here the third property. That's why we are multiplying exponents. Now, are they having the same base? Yes. But 3 is understandable that it has an exponent of 1. Anyway, 3 to the 1 is still 3. If they have the same exponent, then we have to equate. If they have the same base, then we have to equate exponents. You have 1 equals 2x. But we're going to solve for x. So we have to divide both sides by 2. Divide here by 2. Cancel that. So therefore, x is equal to 1 half. At this point, the left side is actually 1 half and the right side will become x. We can actually switch to make it x equals 1 half. Now, if you will try to check if this is really correct, you can actually substitute 1/2 to your x from the original problem. In that case, if you have 3 equals 9 to the 1/2, I am sure that 9 to the 1/2 is equal to 3, which is equal to 3, the left side. So this is really correct. This is now our answer. Let's proceed to number 2. Number 2 is given by 16 x to the x plus 1 equals 64. Now, as what you have observed, both are actually multiples of 4. Or it could also be multiples of 2. You can actually do that. So what my point is that you can actually have a base of 2 or a base of 4 in this particular figure. But in my case, I will be using 4 as my base. 16 can be written as 4 squared. I substituted 16 with 4 to the 2, but we have exponents in here, so we have to copy x plus 1. And 64 can be written as 4 raised to the power of 3. Because this is 4 times 4, 16 times 4, that is actually 64. Again, our main objective is to have the same base. And this is what we did. So on the left portion, this is using again the third property because we have the conflict of exponents. But you have to be careful. It's because your exponent to by the base 4 is that you are going to distribute that to every term of the second exponent. So this will become 4 raised to the power of 2x plus 2, which is now equal to 4, 3. 4 to the 3. Are they having the same base? Yes. Therefore, we can now satisfy the definition. So this is now 2x plus 2, which is equal to 3. We actually equate exponents because they're having the same base already. Now we have to transpose 2 to the left. So from positive 2, it will become negative 2. Again, if you are going to transfer, it will have a different sign upon transferring. So the left side will become 2x equals 3 minus 2. But what is 3 minus 2? 3 minus 2 is actually 1. So this is now 2x equals 1. So let us continue here. So this is now 2x equals 1. If we're going to solve for x, then we have to divide both sides by 2. Dividing both sides by 2 to get x. So that you're going to cancel that, and x is equal to 1/2. This is now our answer. You can actually do the checking by substituting x equals 1/2 to here on your original problem. So if you have x is 1/2, that is x plus 1, that would be 1/2 plus 1 or 3 halves. 16 to the 3 halves, that is actually equal to 64. Now, if you're going to ask me, can we use a base of 2? Are we going to arrive with the same result? Yes. Let's try to check. Let me erase the first. Okay, what if we will be using the base of 2 from this example? So we have here 16 raised to the power of x plus 1, which is equal to 64. Now, what if you are going to prefer 2 as our base? So 16 can be written as 2 times 2, 4 times 2, 8 times 2, 16. So that would be 2 raised to the power of 4. This is the corresponding exponential figure of 16. But we have x plus 1, so I want you to copy that. 64 can be written as what? 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So that would be 2 raised to the power of 6. That is the corresponding exponential figure of 64. Are they having the same base? Yes. But wait, we are going to multiply exponents from this part. So this is now 2 raised to the power of 4x plus 4, which is now equal to 2 to the 6. Are we having the same base? Yes, we can now equate exponents. So we have 4x plus 4 is equal to 6. But we have to transfer 4 to the right. So this is now 4x is equal to 6 minus 4, which is now equal to 4x equals 2. So in finding our x, we have to divide both sides by 4. Cancel that. So what's left? X equals 2 over 4. But what is x equals 2 over 4 divisible by 2? So this is just equal to 1 half. In short, this will become 1 half. Are we having the same result? Yes. So you can actually do that. Let's proceed to our third example. Let me erase this part. So our third example is that we have here 5 to the x equals 25 raised to the power of 2x minus 3. Now, what is the base of the left? It's 5. The base on the right is 25. Now, 5 is already in its base form, meaning to say you cannot transform 5 into another exponential figure because this is already in its simplest form. How about 25? 25 is a perfect square which can be written as 5 squared. So we are going to touch 25 and do not touch 5. All you have to do is to copy. So this is now 5x, but 25 can be written as 5 squared. Raised to the power of, you have to copy your exponent. So we have here 2x minus 3. This is actually following the third property of exponential equation. So we have to multiply exponents. Again, you have to distribute to every term of your second function. So we have here 4x. That's the product of 2 and 2x. 2 times negative 3, that's minus 6. But on the left side, you have to copy. Are they having the same base? Yes. So therefore, we can equate exponents. X is equal to 4x minus 6. Now, we are going to transfer 4x to the left. So from positive 4x, it will become negative 4x plus x equals negative 6. What is the result of negative 4x plus x? Again, the simplified figure is that we are going to subtract because they are having different signs. So negative 4 plus 1, that would become negative 3x, which is equal to negative 6. At this point, we are going to divide both sides with the negative 3 because our goal is to solve for x. So we are going to cancel negative 3. What's left? Continuation will be here. So this is now x is equal to, what is negative 6 over negative 3? That's positive 2. This is now our x value. Another example, if you have here number 4, this is 7 x squared plus x is equal to 49. 7 is already in its simplest form. So you cannot transform this into another exponential figure. But 49 is a perfect square, which can be written as 7 squared. So just copy the left portion, and 49 can be written as 7 squared. Are they having the same base? Yes. Therefore, we are going to bring down exponents or equate exponents. So we have x squared plus x is equal to 2. But we have to transpose to the left. From positive, it will become negative. So we have here x squared plus x minus 2 is equal to 0. Now our goal is to solve for x. But this is in a form of standard form equation, which is in the form of ax squared plus bx plus c is equal to 0. Now, there are actually two ways in finding your x. It might be that your quadratic function that you have arrived is factorable. So we are going to employ the process of factorization to solve for x, or using the quadratic formula. But in this case, is this factorable? Let us see. Negative 2, what are the factors of negative 2? 1 times negative 2. What else? Negative 1 times 2. These are the only factors because 2 is actually the only even prime number. Now, if you will try to add 1 and negative 2, it's actually negative 1. If you're going to add negative 1 plus 2, it's actually 1. Why are we having that trial? It's because we have to consider the middle numerical coefficient. This is understandable that we have a middle numerical coefficient or a number of 1 beside x. Now, what I'm trying to point out is that if you're going to add factors, make sure that the sum will be the middle, which is positive 1. So which of the two will give the sum of positive 1? It's actually the second. So this will fall under the sum and product of the roots. So this is actually the factor. These are the factors. So we have here x minus 1 because we have here negative 1. And then this is 2, which is what? X plus 2 equals 0. Now at this point, we can actually equate each with 0 according to the zero factor property or the AB method. So at this point, we will erase this part so that we're going to occupy. So this one can be written as x minus 1 equals 0. And the other one would be x plus 2 equals 0. So you can give 0 to the first, x minus 1 equals 0, and x plus 2 equals 0. Because in solving for x minus 1 equals 0, you can actually equate both sides or divide both sides with x plus 2. to find this. And to find this one, you can actually divide both sides with x minus 1. So cancel x minus 1, 0 over x minus 1, that would be 0. So what's left? X plus 2 equals 0. So how to solve for x? Transposing -1 to the right. From negative, it will become positive. How to find x here? Transposing to the right. From positive, it will become negative. So this is now -2. These are now the answers. So at this point, we have two answers. So it would be possible that we have actually two answers in one particular exponential equation. Because if you are going to substitute 1, this will become 1 squared plus 1. That's 2. What is 7 squared? 49. So 49 is equal to 49. How about -2? If this is -2 squared, that would become 4 minus 2, that's 2. 7 squared, still 49 equals 49. So there are actually two real numbers that would satisfy our exponential equation. If you're going to ask me, can we use the quadratic formula? Yes. But make sure that it will follow from the standard form equation as what I have said a while ago, which is a x squared plus bx plus c equals 0. So we have to base it from here. This is the second way in finding your answers by using the quadratic formula. But what is your a? Understandable that your a here is 1. So we have a is equal to 1. What is your b? Your b here is also equal to 1. Invisible beside x. How about c? -2. You have to carry the negative because the standard operation here is positive. So this is now c is equal to -2. So by using the quadratic formula given by -b plus minus the square root of b squared minus 4ac over 2a, then you can actually substitute the a value, the b value, and the c value. Okay, let's do that. Continuation over here. Please be guided. So this is now x is equal to negative. What is your b? It's 1. So we have 1 plus minus. Copying from here. Square root, copy. What is your b value? It's 1. So you have here 1 raised to the power of 2 minus 4. What is your a? It's still 1. But what is your c? Your c value is -2. So basically, we are using here substitution property over what is your 2? A, we have 2 times 1. Your a will be replaced by 1. Simplification, this is now equal to -1 plus minus the square root of what is 1 squared? 1 squared is equal to what? 1. -4 times 1, -4 times -2, that's positive 8 over 2. Simplify, so x is equal to -1 plus minus square root of 9 over 2. Why 9? It's actually 1 plus 8, that's 9. Copy -1, copy plus minus over 2. But what is square root of 9? Square root of 9 is just -1 plus minus square root of 9 is 3 over 2. Now at this point, we can have two solutions, the positive side and the negative side. Okay, let's do that. The first one is that it will give x equals -1 plus, we are basing on the plus side. And the other one is that x is equal to -1 minus 3 over 2. As what you've observed, we have double sign, so we are going to separate. This is our first. And this is our second. Now, what is negative 1 plus 3? That's 2 over 2. What is 2 over 2? That's 1. Here, what is negative 1 minus 4? That's negative 4. Over 2, the quotient will become negative 2. So we have 1 and 2 as our answer. Do we have the same result? Yes. Do we have the same result? So what I'm trying to point out is that you can actually use the two ways, the factoring and the use of the quadratic formula. But basically, in using your quadratic formula, usually you will be using the quadratic formula if your standard form equation ax plus bx plus c equals 0 is not factorable. So you don't have a choice but to follow this formula. Another example, let me erase this. Assuming we have here 10 to the x is equal to 1 over 10,000. At this point, we are going to focus on the right side because 10 is already in its simplest form, meaning you cannot transform 10 into another exponential figure. This is already in its base form. So copy that, 10 to the x. But you can actually let your denominator be on top. Bring that up, so this will become 10,000 raised to the power of negative 1. Why? We are actually following the property a to the negative x equals 1 over a to the x. Remember, one of the properties says that if you have a to the negative x, that's equal to 1 over a to the x. And this one is actually following from this. So if you're going to let our denominator be on top, from positive exponent, it will become negative. So this is understandable that 10,000 has an exponent of 1 because 10,000 to the exponent of 1 is still 10,000. Bring that up, that will become 10,000 to the negative 1. Why are we doing like this? So that our base will become 10,000 and 10,000 can be written with a base of 10. 10 times 10, 100 times 10, that's 1,000. Times 10, that would be 10,000. So 10 raised to the power of 4. So this will become 10 raised to the power of 4. 10,000 is being replaced with 10 to the fourth. But wait, we have here negative 1. Don't forget. So we have here 10 raised to the power of x. There is a conflict of our exponents. So we are going to multiply. So we have 4 times negative 1. That would be negative 4. And this is 10 raised to the power of x. Are we having the same base? Yes. So therefore, we are going to equate exponents. This is now our answer. Okay, last example. Assuming we have here 3 to the x is equal to 9 raised to the power of 2x minus 1 times 27 raised to the power of 4 minus 2x. At this point, what are the bases? 3, 9, and 27. But what must be our base here? 3. 3 could be the base because 9 can be written as 3 squared and 27 can be written as 3 cubed. 3 is already its base form, so you have to copy. So this is now 3 to the x. But 9 can be replaced with 3 squared. But we have exponents, don't forget. So this is now 2x minus 1 times. What is 27? That's 3 cubed. Because 3 times 3, that's 9 times 3, 27. But oops, we have still exponent. So we have to copy that. Are we having the same base? Yes, because primarily that's our main purpose, to arrive with the same base. So we have to copy 3x on the left side. But in terms of this point, we are going to distribute 2 to every term of your function. So this is now 3. 2 times 2x, that will become 4x. 2 times negative 1, that will become negative 2. Times 3. Again, we're going to multiply 3 to 4 and multiply 3 to negative 2. So this is now 3 to the 12 minus 6x. Now at this point, this is actually following from the property a to the x times a to the y, which is equal to a to the x plus y. Why? We have here a, we have here its own exponent, a multiplication operation, and we have 3, which is a, and we have another exponent. So basically the right side, this right side here is actually following this concept, one of the properties of exponential, such that if you are multiplying two exponential figures with the same base, then you are going to add exponent. And this is what we're going to do. 3x. So from a times a, that's a. In short, 3 times 3, that is still 3. And we have to add exponents. So this is now 4x minus 2 plus 12 minus 6x. Simplifying our exponents on the right side. So this will become 4x minus 6x, that's negative 2x. Negative 2 plus 12, that's positive 10. Are we having the same base? Yes, so therefore we are going to equate exponents because it has the same base. Continuation on this part. So again, we have to simplify. X is equal to negative 2x plus 10. I just copied from it here. Transposing negative 2x to the left, it will become positive 2x plus 10. I mean equals 10. Simplifying x plus 2x, that is 3x equals 10. Divide both sides by 3. Cancel that. So therefore, our x value is 10 over 3. This is now our answer. Thank you everyone for listening.